Yeah, so what I like about this is they're just giving me M, they're giving me A, they're giving me K, and they're not telling me what those numbers are, which is good because then I don't have to use my calculator. I just have to do the math. So it says a block of mass M is attached to a spring fixed to a wall. The mass oscillates on a frictionless horizontal surface with an amplitude A. So I guess if I make the picture, we would have we're going to have a spring like this, and then we're going to have the mass is going to oscillate like this. So it's going to go back and forth, back and forth, back and forth, about around some equilibrium position. That's what it's going to do. So the question is, it says the mass oscillates on a frictionless surface. The spring constant is K. In terms of the given quantities, what's the speed of the block when the mass is at 1/2 its amplitude? Well, the speed at 1/2 its amplitude will not be the maximum velocity. On the A version, I think it was what's the amplitude or what's the maximum velocity, which would be at its amplitude. But I want half that. So that's what makes it slightly, a little bit more complicated than the A version, I think, on this. I'll concede on this problem. Because I know that when all of the energy is kinetic, which is when it's at its equilibrium position, it's going to equal all the energy when it's at its stretch position, which will be elastic potential energy. So I know that the formula here for maximum, 1/2 mv squared equals 1/2 k. Now, what I'm going to do here is I am going to put in the maximum, which is at the amplitude. When it's at its full amplitude, all the energy is potential. When it's at its when it's at its equilibrium position, it's all kinetic. So at some point, it's going to be at its full amplitude, and that's how much energy it's going to have. That energy will equal the energy that it has when it's at its equilibrium position. All right, so that's going to be its maximum. When it's at its maximum velocity, that will be at its equilibrium position. So if I solve this, well, first of all, I'm going to solve it for the V max. And then, once I know that the energy will be, like I know when it's at half its amplitude, it's actually going to be at half its energy. And the reason for that is kx, that if I double the x, I double the energy. Let me put it this way, like if I take a ball and I throw it up in the air, if it goes up to 30 feet in the air, all the energy is potential energy. If I want to know what the energy would be when it's at 15 feet, I know it's going to be half of the potential energy, because think of the formula, mgh. So mgh means that if whatever energy it has at 30 feet, when it's at 15 feet, it's going to be half of the energy that it has at 30 feet. So in this problem, I know that whatever I solve for whatever I get here, it's going to be half of that at the, yes? Right, I'm solving for the max just because I want to know how much energy I have to work with. Because I don't know what it is, so I know that it's all the energy here will equal that amount. So I've got at least a relationship here that I can figure out the maximum velocity. So the maximum velocity, so solving this, I'm going to solve this for what's the speed of the block when the mass is at 1/2 of its amplitude. I'm solving it right now for its maximum velocity, not its speed when it's at half. Right now I'm solving it for its max. So if I do that, I'm going to get V max is going to equal, first of all, I can cancel out halves on both sides, and I'll get K A squared over M. Okay, so if I rearrange this equation, I'd be bringing the M down there, And then that would equal V max squared. So that's going to equal the square root of Ka squared over M. So solving that, I'm going to get Ka squared. Whoops. Oh, I'm sorry. I don't even have to do that because that's my maximum velocity. It's not like delayed because I'm outside of the range of where this thing works best. So it works best inside that square. Okay, so that's my maximum velocity. So what I can do now is notice that the velocity squared. Whoa, the velocity is squared over here, and the A is squared over there. So they sort of have a similar effect, right? If this is doubled, then the A is doubled. If this is if this is doubled, then the energy is 4 times. And if that's 4 times, then that means that the A is doubled. So there is a relationship, a direct relationship between amplitude and velocity. You follow that? Because they're both squared on both sides. So whatever I have for my answer here, then I know that my amplitude is directly proportional to how much energy I have. Because when I'm at the full amplitude, I'm going to have all potential energy. When I'm at half the amplitude, I'm going to have half the energy. So it's directly related. So that means that if V max is at the full amplitude, and I want to know what it is at half the amplitude, I just have to take that answer and divide it by 2. So you can do it like this and just say, well, divided by 2. There's my answer. That's now no longer V max. That's V at half the amplitude. Another way of doing it is I could put it inside the square root or put it up here as 1/2. So I could write the answer as V equals 1/2. And I could take out the A if I want, because the A is a perfect square. And I could write that as square root of K over M. So that's one way of writing it, which would equal what I have on the board over here. Another way that I could write the velocity is I could just keep everything inside the square root and say it's going to be Ka squared over 4M, because the 4 would come out as a 2, and the A could come out, so that's where that part comes from, but I could have just left it all inside. So this answer, or this answer, or this answer, all 3 of those, even though I don't like complex fractions like this one, fractions inside fractions, I mean, for this one, if you got to that point, I gave you the points. All right, but you cannot right off the bat make that A over 2, because that's not going to represent the velocity there, because it doesn't represent all the energy. When it's at A over 2, half of that energy is going to be kinetic. All right? All right, any questions with that one?